Hello everyone, this is Aditya and today we are going to calculate the velocity of rocket at any instant, and of course all the calculations will be an ideal calculation. So now let's start with the video, but before that please do like, share, subscribe my channel and please support this video. Now let's start. So let's understand this. So let's draw a rocket. My drawing is not good, so just bear with it. So suppose this is your rocket, okay, and of course it is an ideal case, right? So suppose the fuel is getting ejected like this and it is going in upward direction, right? Of course. So notice one thing, that what will the force in the upward direction? It will be equal to u times lambda. Okay, let me define certain terms. Lambda is the amount of fuel ejected per second and u is the exhaust velocity, right? At what velocity the fuel is being emitted or ejected, right? Or exhausted basically, right? So which is causing an upward thrust in the rocket, due to which the rocket moves upward, right? So what are the forces acting on the rocket? Ideally there are two forces only. One is this one and other is the gravitational force mg, right? Okay, so how do we calculate its velocity? Well, if we assume that u and lambda are constant, then we can easily find its value. How? Let's see. So we know that ma is equal to, or let me explain it in a better way. Since the net motion of the body is along upper direction, so u lambda minus mg must be equal to what? Must be equal to ma, correct? Okay. Okay, so from this, how we will go to the velocity? Well, before that, you should know that this mass is not the actual mass, the initial mass of the rocket, because the fuel is being getting ejected. That is why the mass at any time t is given as the initial mass. Mass at time is equal to 0 minus lambda times t, right? Okay, but why lambda times t? Well, notice one thing, that lambda is equal to dm by dt, right? So it means that dm is equal to lambda dt, right? Okay. So whatever time passes, it will be equal to, the final mass will be equal to the initial mass minus the amount of mass lost, right? So that is why dm, and when you integrate, you will get lambda t, right? Basically that. Okay. So from this, you can say u lambda is equal to m times a plus g, correct? Hence, we get that a plus g is equal to u lambda by m, or you can say a is equal to u lambda by m minus g. Okay. Now you know one thing, that from this you can say that m is equal to m naught minus lambda t, right? So let's substitute its value. So we get a is equal to u lambda by m naught minus lambda t minus g, correct? Okay. So this is the expression. Now from this, how we will get the velocity? Well, you know that acceleration is equal to dv by dt, and this whole expression is just dependent upon time, since we know that u is constant, m naught is constant, lambda is a constant, g is a constant. So from this we can easily calculate the velocity. How? So we have dv by dt is equal to u lambda by m naught minus lambda t minus g. So from this we get that dv is equal to u lambda by m naught minus lambda t dt minus g dt, right? Okay. So let's integrate this expression, right? So at t is equal to 0, the velocity will be the initial velocity. Let's assume v naught, right? Okay. And when time is equal to t, then velocity suppose v, right? Now let's integrate this. So we get v minus v naught is equal to 1 upon negative lambda into u lambda into the natural log of the quantity m naught minus lambda t, and the limits are from 0 to t minus gt, right? Okay. Now lambda and lambda gets cancelled, right? So we get v minus v naught is equal to negative u natural log of m naught minus lambda t. The limits are from 0 to t minus gt. Now let's solve it further. So we have got this expression. Now let's substitute the limits. So v minus v naught is equal to negative u multiplied by this quantity. Of course, you will have a natural log also. Natural log, right? So when you substitute t is equal to t over here, so you get m naught minus lambda t, And when you substitute t is equal to 0, you get negative ln of the quantity m naught, and here of course you have a negative gt, right? Okay, so v minus v naught is equal to negative u multiplied by the quantity, the natural log of the mod m naught minus lambda t by m naught minus gt, right? Okay. So you get v minus v naught is equal to u natural log m naught by m naught minus lambda t minus gt, right? So you get the velocity is equal to v naught plus u natural log of m naught by m naught minus lambda t minus gt, right? Okay. So this is how you calculate the velocity of rocket at any instant. And when you calculate it in vacuum, when there's no gravitational field, in that case you substitute g is equal to 0, so you get expression as v is equal to v naught plus u natural log of this quantity, right? So if we assume the gravitational field also, then you will get this expression, right? So this is the general expression for any rocket if you are considering the gravitational field too, and of course it is an ideal case. There are of course many other things we have to consider while making a real rocket, but we are not discussing that one, right? So this is the basic idea. So I hope so that it is clear that how we calculate the velocity of rocket ideally, and of course there are many more things to be discussed in this, like how I calculate this value u lambda and many other things, which we'll discuss in some other video. But till then, try to understand this one, and of course please do like, share, subscribe my channel, and please support the video for more such videos. And of course I make many kinds of lectures also for engineering mathematics and for engineering physics, also for bachelors and masters, and of course I make videos for 11th and 12th also. So bye bye, take care, and all the best.